we're graphing, doing a review on all the different trig functions and their graphs. And so here we go. So my A is -1 because it's negative sine. My B is actually 1. That's not my period. Remember, my B is just what's going to affect my period. My normal period is 2 pi. My normal period is 2 pi, and then I have to divide that by my B. So for this one, it's still going to be 2 pi. Okay, and then because this is just sine of x, right? So I could put parentheses there. So I have no d. My d is actually 0. It'd be different if it was parentheses like that, then I would have a d, right? It'd be -1. But it's not, so I have no d. And then my phase shift is right here, that +1, so c is 1. Okay, so normal period length is 2 pi. Then to find the interval length, we take that period and we divide it by 4, so we get pi halves. We normally start at 0, right? Our x is 0, but we got to add our d, which is 0, so it stays there, and then we add our interval length. So 0 plus pi halves is pi halves. Add another pi halves, that's 2 pi halves, or pi. 3 pi halves, and 4 pi halves, which is 2 pi. Okay, and then we can do our y values, which are normally for sine 0, 1, 0, -1, and 0. So it'll be here, here, back to 0, back to here. So this would be 1, 0, -1, and then back to 0 at the end, right? So that's what our normal graph looks like. But now we have to multiply these by our a, so that's still 0. That's -1, because -1 times 1 is -1. 0. This becomes +1, and this stays 0. So now these are going to get switched, right? So we're going to go, and normally I just usually leave this, right, just like this, and I just adjust my y-axis. I'm going to leave my y-axis the way it is, just so you can see something different, just in case you see something different on a test or quiz, you're not perplexed by it. Okay, so my points now are 0, -1, back to 0, up to +1, then back to 0. Okay, so now I can delete these original ones that I had. Okay, so that's how my graph looks now. And then I got to add my c, right? So now I got to add this c value. I'm going to add 1 to all of these. And again, I'm going to leave have my 1, 0, -1, my y-axis. I'm going to leave that. I'm not going to change it this time. So I get 1, I get 0, I get 1, I get 2, I get 1. Okay, so I'm going to go 1. Oops, my point right here. I'm going to go 0. I'm going to go back to 1. And then I'm going to go to 2, so I need to go up to 2. Yeah, sorry. Up to 2, so I need to make a mark here for 2. So I'm up at 2. And I'm back down to 1, alright? That makes sense. Okay. And I'm back at 1. So you can see my final one goes 1, 0, 1, 2, 0. And then I can erase these blue ones here. Oops, erase. Okay, so that's how my graph would look if I didn't change the y-axis, which some of you might do already. You notice that what we call the midline right through here is the center halfway between the two, oops, all the way down here and here. Halfway between from the crest to the trough, right? Halfway between, and the amplitude is this distance from the middle to the top, right? -1. So there's what the graph looks like. Oops. Okay, so that's where the graph looks like. Okay, so here's the second one, dealing with cosine this time. Our A is -3. Our B here is 2, so that affects our period, right? We take our normal period of cosine, which is 2 pi, we divide by b, so that's 2 pi divided by 2, which is just pi, so it's going to be pi long. Our phase shift, nothing's inside the parentheses being subtracted from x, right? So our d is 0. And nothing's being added to this after we take the cosine and after we multiply, right? So that our c is 0 as well. Okay, so we got our period length, and now to find our interval notation, or interval length, sorry, interval notation. Interval length, we take our period and we divide that by 4, so pi 4s. So we normally start it at d, basically, right, at 0, and then we add our d, so 0 plus d is just d. So really we always start with cosine and secant and cosine and sine and cosecant at our d, which is 0. And then we're going to add that interval length, so that's pi 4s. That's 2 pi 4s. If you want to leave it as 2 pi 4s, that's fine. If you want to reduce it, that's fine too. 3 pi 4s. And then 4 pi 4s, which is pi long, right? 0 to pi is pi long. And that's our period length, right? Okay, then our normal y values of sine are 1, 0, negative 1, back to 0, back to 1. Right? So then we're normally here, up at 1, 0, negative 1, back to 0, back to 1, right? But now we got to multiply it by our a. So that turns to negative 3, 0, positive 3, 0, negative 3. So if you want to, you can just change those y values, right? That's all you have to do. This would now come down here, though, right, at negative 1, and then it would come to 0 and so on. But again, just like the last one, I'm going to go ahead and keep my y values the same there, my y-axis labeled the same. And now I'm just going to adjust this. So negative 2 would be here, and negative 3, say, here. So it goes negative 3, 0, positive 3. So I'm going to come up here to 3. That kind of gets into that, but that's all right. I'll just erase this. So this is 2, 3. Extend that line. So then it comes up 0, 3, back to 0, then down to negative 3, right? Let's extend that. So our graph looks something like this. Let me finish the top here. It comes up like that. Alright. So that's how our graph looks like. I can delete these points that I put down. Okay. So then you can see it kind of changes. Now you see from 3 to negative 3, right, is a total of 6. And I divide that in half, that would be at 0, right? So I have this midline going across what my normal zeros were. Alright, so that's what your graph would look like. Getigraph and Cosecant, that means basically that we're graphing sine, right? We're graphing the y values of sine and then inverting it. Okay, so your a here is 4. Your b here is still 1, right? Because there's nothing on the outside of that parenthesis, and there's nothing in with x. So b is 1. Your d is a negative, right? Because I had to do the opposite of this. So negative pi halves. So instead of starting at 0, we're actually going to start at negative pi halves. And then our vertical shift, nothing's being added to or subtracted after, right? After we take the cosecant of whatever's in there. So our c is 0. So since our b is 1, that means our period should just be 2 pi, right? But I'm going from negative pi halves to, basically, from negative pi halves, I want to add 2 pi to that, and that would be where I end. Okay? And to find that interval length, you take that period and you divide it by 4. And so we get pi halves. So I want to add pi halves. So negative pi halves plus pi halves would be 0. And, well, let's actually do this. Let's keep this at 0. So you can kind of see. So we actually started at negative pi halves. So I'm going to go back this way and go negative pi halves here. And then my next one would be 0, right? Because negative pi halves plus pi halves, my interval length, is 0. And then plus another, this would be pi halves. This would be 3 pi halves. This would be 4 pi halves. Just 2 pi, and then I got to add another. Well, actually we're good. 1, 2, 3, 4, 5. So we're good there at 2 pi. Okay, quick correction, right? Because pi halves plus pi halves. This should just be pi. And it was off by 1. So that should be pi, or 2 pi halves, and this is 3 pi halves. There, that's as far as I need to go. And you can see if I subtract that, right, this should be a distance of 2 pi. So there's a pi halves, there's a pi, there's another half a pi, there's 2 pi. So that whole thing is 2 pi long, which that's what my period was, right? Okay, so got my x's down. Now we need our y values, right? Our y values for cosecant is the same as sine. They start out that way, as 0, 1, 0, -1, back to 0. Right, so let's go ahead and just put those on. But I'm going to put them on right here, right? Because that's where we're going to start, at negative pi halves now. Up to 1, 0, -1, and then back up to 0. Right? Now we're going to multiply this by our c. So I'm going to multiply this by 4, so I get 0, I get 4, I get 0, I get -4, and I get back to 0. Here, because I don't want to exaggerate this out, because it's just, I have to extend it, so, and because it's 4. If it was only like 1, or if it was a 2 or something like that, that'd be fine. But 4 is kind of long. So let's go ahead and switch this now to 4, and this to -4. And then we can go ahead and draw our graph. So that's what a normal sine looks like, right? Let's go ahead and graph cosecant, which would be the reciprocals of that. So here we would, anything at our normal zeros, our beginning zeros, would be vertical asymptotes, right? And now we just invert it from going down to now going up, and going up to now going down. And there's our graph. And go ahead and erase. Make sure you erase these, right? Because they're no longer in there. Okay? And you can also erase these points as well. They no longer exist either, because those are vertical asymptotes. Okay, so that's what our cosecant of this graph looks like. Here I moved it over so you can kind of see like what it would look like if you just adjusted your x-axis. Okay, tangent, haven't covered tangent as much, but here we go. So our a equals 2, our b equals 4. That will help us find our period. Our phase shift is 0, and our c is 0. Okay, so tangent, its period length is normally pi. Okay, so we take our pi and we divide that by b. So we're going to take pi and divide that by 4, so we get pi fourths. Then to find our interval length, we divide that by 4, which is multiplying by 1/4. So we get pi 16ths is our interval length. Then we start at our d. We don't actually start at d, sorry, excuse me. We don't start at d. Normal is where tangent gets a little tricky. Tangent starts at negative pi halves and ends at pi halves. That's its start and its finish. So we're going to add our d to our start, which is negative pi halves, so we still get negative pi halves. And let's go ahead and just extend this and let this be our negative pi halves. So there's our start, and then we want to have our interval lengths, and we'll find out what our interval lengths are, which is pi 16ths. Actually, you already know that, right? So let's take pi 16ths. So we need a common denominator, so we get negative 8 pi 16ths plus pi 16ths. And then we go ahead and add that, and we get negative 7 pi 16ths. And then we can add that again. So negative 7 pi 16ths, and add another pi 16ths, we get negative. Well, let's just keep going here. Once you have a common number, it's pretty easy. So we're going to get negative 6 pi 16ths. Then we're going to get, so I'll just start, and then negative 7 pi 16ths. Then negative 6 pi 16ths, and then you get negative 5 pi 16ths. And the last one is negative 4 pi 16ths. So they're all negative, right? So So I'm just going to change my x-axis, not make this as difficult. Okay, so negative pi halves, we start. Negative 7 pi 16ths. Negative 6 pi 16ths. Negative 5 pi 16ths. Negative 4 pi 16ths. Which is just negative pi fourths, right? So basically, if I was actually to draw it like real, it would be somewhere between here, right? This is all happening, negative pi halves and 0. So that's why I redid this, so I didn't have to graph a little tiny graph. Okay, so then the y values. The y values of tangent. So period is different for tangent and cotangent. They're both pi long. The y values for tangent go undefined, negative 1, 0, positive 1, back to undefined. So our first thing is always undefined, and our last one is undefined. Okay? And then we have negative 1, 0, positive 1. Okay, and now we're going to multiply this by our a, which is 2. So I'm going to actually go down to negative 2, right? And then up to positive 2. 0 is still going to stay 0, right? And undefined will stay undefined. This will just become, this will become negative 2. This will become 0. This will become positive 2. Undefined stays undefined. Okay, so now these are changing. Negative 2, 0, and then positive 2. Okay, and then it kind of just looks like a cubic function. So draw your best cubic that you can. And then it goes closer and closer to these vertical asymptotes. But draw the best cubic that you can. Basically, that's what it looks like. And then we can erase these blue ones here. And so that's what our graph looks like from undefined to undefined. Okay. All right, cotangent. Cotangent also has a period length of pi, so we want to divide that by our b. Our a is 1, our b is also 1, but our phase shift, we're subtracting from our x there, so it's actually going to be a positive pi halves. And then our c, we're not adding anything afterwards, so our c is 0. Okay, so we take our pi and divide it by our b, which is 1, so we get pi. And then we normally start cotangent. We start cotangent at 0, so we can just add our d to that. So 0 plus pi halves. So we're actually going to start at pi halves. Okay. So again, you could just adjust your 0 here and make that pi halves, but I'm going to show you so it looks a little different than before. Okay, and we'll let this go ahead and be 0. Okay, and now we can go ahead and add our interval, or find our interval. We take our period and divide it by 4, so it's pi fourths, and that's what we're going to add to our pi halves here. Okay. So we're going to take pi halves, and we're going to add pi fourths. So that'd be 2 pi fourths. So that'd be 3 pi fourths. So 3 pi fourths. So 3 pi fourths. Oops, fourths. And then add another pi fourths, which is pi, or 4 pi fourths. 5 pi fourths. Okay, and then that's as far as we need to go, right? Because that's pi long. Or actually not, we would need to go one more. 6 pi fourths. Which is 2 pi thirds. Or sorry, 3 pi halves. So from pi halves to 3 pi halves, it's a distance of pi, right? And that's what our period length is, pi. Okay. Then cotangent, this is how the y values of cotangent. The y values of cotangent, again, go from undefined to undefined. But it goes 1, 0, negative 1. Okay, so it goes from undefined to undefined. Then it goes from 1, starts at 1. Oops. My starting spot is not 0 anymore, right? So I need to erase that. My starting spot is at pi halves. Right? So then the first one is at 1. Actually, technically, this would be my second one, right? Because my first one's at undefined. Then 0, then negative 1. Okay, and then we multiply those by our a, which is 2. And I'm just going to go ahead and change these, right? So positive 2, negative 2. So this becomes 2, 0, negative 2, undefined, stay undefined. And then we can just go ahead and draw our kind of cubic looking function. That I'm worse at the bottom ones here, but it looks something. And then it gets closer and closer to the undefined. Alright, there's that one. Okay, so secant, basically graph and cosine, and then switching it. Okay, so here, normally it's 2 pi. We divide that by our b, so we get 2 pi over 1, so it's still 2 pi. We start at our d. Our d is negative pi fourths. So, negative pi fourths. And then we add our interval. Our interval is taking our period and dividing it by 4. So that would be 2 pi over 4. Might as well leave it with the 4, right? So we have common denominator. Now we can add for our first interval. And we get pi fourths. Add another one, we get 3 pi fourths. Add another one, we get 5 pi fourths. Add another one, we get 7 pi fourths. And that's as far as we need to go, right? Because that would be 6 pi fourths long, right? 7 pi fourths minus a pi fourths, that's 6 pi fourths. Let me make sure I added right. 1, 3, 5, 7. And yep, because this is a total of 8 pi fourths distance, right? Here's a pi fourth, 2 pi fourths, 3, 4, or sorry, 1, 2, 3, 4, 5, 6, 7, 8. Total distance of 8 pi fourths. So there is a 2 pi long. Well, geez, going crazy here. All right, so then our normally cosines are at 1, 0, negative 1, back to 0, back to 1. So it looks something like this, right? Normal cosine does. But then we multiply those by our a, which is 2. So I'm going to change this. Well, let's go ahead and just do 2 here. It's 1, 0. Let's do, that's negative 1, I guess. We'll do negative 2 down here. Okay. And so those are going to multiply by 2, so they become 2, 0, negative 2, 0, 2. Alright. Now we add our c, which is 0, so that doesn't change that. So now we can go ahead and invert this, right? Our zeros, our original zeros, are going to become vertical asymptotes. And our going down is now going to come up. Our going up is now going to, or actually this one was going down, that one's going up. They invert, right? And this one goes down like that. And then we can erase these. Erase that point as well, we don't need that. So there's how our kind of graph looks like. Okay, add a little bit more. Now we have an A, it's 2. We do have a B now, it was 1/2. That means when we divide by our B, 1/2, we are multiplying by 2. Our D is negative pi thirds, and our C is 1. So we got a lot to do here. So normally cosecant deals with sine, so our period length is 2 pi. 2 pi divided by b is 2 pi times 2, which is 4 pi. So our period is 4 pi. We normally start at our d, and our d is negative pi thirds. I'm just going to change my 0 to negative pi thirds, make it easier on ourselves, right, when we're graphing. The reason I was doing the other ones basically is for when you look at a graph, how can you write the equation? That's why I was kind of changing them. But if you're actually just graphing, you might as well just change your x-axis and change your y-axis, right? Because then you won't have to go through the problems that I just did and just be confused. All right, so we start at negative pi thirds. Now we're going to add our interval length. That's taking our period and divide it by 4. So that is pi. And if we convert it to thirds, right, because we're going to start at negative pi thirds, so we can get 3 pi thirds. And then we add that to negative pi thirds, we get 2 pi thirds. And we add another 3 pi thirds, that's 5 pi thirds. 8 pi thirds. I don't know why I put a 6 there. So that's 4, and I need one more. You gotta have 5 of them for one period length, right? So that's 11 pi thirds. Okay, so now we can go ahead and graph our y values, which is cosecant, so that deals with sine, which is 0, 1, 0, negative 1, back to 0. So 0, 1, 0, negative 1, back to 0. We multiply those by 2. So instead of a 1, now we have a 2 and a negative 2. And then we add our c, which is plus 1. So change this to 3. Change this to negative 1. Okay, and then we can graph. So this what I'm graphing right now is just sine, right? That's sine. So then I got to invert it, right? So my original zeros are now going to become asymptotes, however you want to say it. Your hills become valleys, and your valleys become hills. So then we can go ahead and erase our sine, right? Because we're not graphing sine, so we can erase those points. Oops, shouldn't erase that point though. Let's put that point back in there. Okay, so there's your graph for you. All right. Okay, got 4 more. So we have part A is negative 2. We're graphing secant, which is basically cosine, right? So the y values would be 1, 0, negative 1, 0, back to 1. So this is 1, 0, and 1. But then we're going to multiply by our a, right? So that becomes negative 2. So instead of right here, right here, right here, right here, right here, now it's going to flip and it's going to go down here, right, middle, up, back down to negative 2. And then we can just change these. Instead of 1 and negative 1, it's going to be 2 and negative 2. And then we're going to add our c, right? So our c is 4, so 2 plus 4 is 6, so now this becomes 6. And negative 2 plus 4 is positive 2. So we can still see this is a distance, right, of 4, right? From 6 to 2 is a distance of 4. And then if you split that difference in half, right, your midline would be 2, and that's our amplitude distance from the middle up. So if you take from the trough, the lowest part, to the highest part, the crest, right, that distance divided by 2 is always your amplitude. Okay, so here we can go ahead and draw cosine, and now we can do secant, right? Secant would be the inverted or reciprocal of that. So if I invert this, my zeros, my original zeros, become asymptotes, and then my valleys become hills, and my hills, and then my hills become valleys. Right, and then we can go ahead and delete these. Delete that point because we don't need that. Delete that point because we don't need that. Still need that point, and still need this point though. Okay, so there's kind of our graph. Now we need our x's, right? We need an x value here, an x value here, 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 and here. So we take our normal period length and we divide it by b. So this one's the tricky one, right? Finding that b. That's where we got to take this middle. We got to factor out what's being multiplied by x. So if we divide out, we divide that out, and our b becomes on the outside. So we get x minus pi halves. So that helped us find our b, which is going to help us find our period, right? 2 pi divided by our b, which is 2, is pi. So that's our period. But it also helped us find our d, right? Because now our d is being what's added to or subtracted from, but it's always the opposite. So it's going to be a positive pi halves. And that's where we start, right? For sine and cosine, secant, we always start at our d. So we're going to start pi halves, and then we're going to add our interval, which is taking our period length and dividing that by 4. So pi fourths. So if I switch this one to 2 pi fourths, which is pi halves, and then I can add my interval, which is pi fourths, so this becomes 3 pi fourths. And then 4 pi fourths. Oops, sorry, up top. Fourths. 5 pi fourths. And 6 pi fourths. And we can see if we subtract those, 6 pi fourths minus 2 pi fourths is 6 pi fourths minus 2 pi fourths is 4 pi fourths, which is pi, right? Which is our period length. Okay, so that one's done. Okay, so here we go, just graphing regular sine, right? So our A is 2, our B is 2, but we need to rewrite this, right? So if we divide by 2, well, dividing pi halves by 2 is like taking pi halves and multiplying it by 1/2, which is pi fourths. So our period, so that number in there. So we can really write this equation like this. Let's put sine 2 times sine of 2 times the quantity x plus pi fourths, and then we add 3. Right, so that's the same equation right there. Alright, so now we know our b, and our d we do know too, right? It's the opposite of the inside, which is negative pi fourths. So we're actually going to start at negative pi fourths instead of 0. So we got shifted over. And then we're going to go ahead and add our interval length. Well, that's taking our period, which is 2 pi divided by b, which is 2, that's pi. And then taking that and dividing by 4 to get our interval length. And then we're going to add it, so we get 0, we get pi fourths, we get 2 pi fourths, and we get 3 pi fourths. And if we subtract those, right, well, basically 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths. 4 pi fourths is a pi, and that is our period length, right? Pi. Okay. So if you just find the absolute value or the distance from your start to your finish, that's always your period length, right? Okay, so we got the x's. Now we need our y's. Well, our normal y's for sine are 0, 1, 0, -1, back to 0. But here we multiply it by our a, so it becomes 2, 0, 2. And then we add our c, which is 3. So this becomes, instead of 2, we add 3, which is 5. 0 plus 3 is 3. So we can still see that distance from 5 to 3 is 2, which is our a, right? And then 2 plus, or -2, that'd be -2. -2 plus 3 is +1. Right, and we take 5 minus 1, that's 4, that's a distance 4. We divide that by 2, right? We get our amplitude. Okay, so then we draw our sine, and that's all we need to do, right? Because this is not cosecant, it is just sine. So our graph is done. Okay, graphing just cosine here, so that's nice. We don't have to invert it. Our b is 1 because nothing's being multiplied by x. That means we don't need to factor anything out. And our phase shift, our d, is the opposite of the inside there, so it's positive pi. So that's where we're going to start as pi, and then we're going to add our interval length. Well, we got to take our period, which is normally 2 pi, divide that by our b, which is 1, so we still get 2 pi. And to find that interval length, we take that period and divide it by 4. So we get pi halves. And then we're going to add it to our pi, which is just 2 pi over 2, right? That's still pi, because we started at our phase shift. So our first interval would be a 3 pi halves, 4 pi halves, 5 pi halves, and 6 pi halves. Okay, and if we take that distance, which is 4 pi halves, divide, right? 4 pi halves is 2 pi, right? Our vertical is our c, which is 2. So now we take our normal y values, our 1, 0, -1, 0, 1. And then we go ahead and multiply by our a, so now it becomes 3, 0, and -3. So 3, 0, -3, and then we add our c, which is 2. So 3 plus 2 is 5. 0 plus 2 is 2, and -3 plus 2 is a -1. And we can go ahead and graph our cosine. Maybe remember it's curvy. It's not a doesn't look like an absolute value. It's curvy, right? It's got a wave-like pattern. Okay, so there's our graph. All right, graph and tangent. Like I said, tangent normal period is pi, and our starting spot is -pi halves, and our ending spot is pi halves. Okay, so our a is 2. Our b, we're going to have to work that out, right? Our b, we're going to have to factor out what's being multiplied by x, get it on the outside of that parentheses. So dividing by 1/2 is like multiplying by 2. So if we multiply these both by 2, it's the same as dividing each of them by 1/2. So that would be x minus pi. Or sorry, still be 1/2 on the outside. So 1/2 is on the outside. So 1/2 over 1/2 is 1. Pi, -pi halves over half is like taking -pi halves and times that by 2. So the 2's would cancel out and I get -pi. And then if you would distribute this right here, if you distribute that, you would get back to that original, right? Okay. Alright, so there's our b. So we can take our pi and divide that by 1/2, which is timesing by 2. So our period length is 2 pi. Okay, and then for our interval length, we're going to take that 2 pi and divide it by 4, which is pi halves. So period is 2 pi, interval length is pi halves, and we start at -pi halves. The start is at -pi halves, but we got to add our d to that, so we add our d, and our d is positive pi. So our b was pi half, or our b was a half, our d is pi, and our vertical shift is -3. Okay, so we take -pi halves, and we add our d, and our d is pi, so that's 2 pi over 2, so we get pi halves. So we're actually going to start at pi halves instead of -pi halves. Okay, and then we're going to add our interval, which is pi halves, so that becomes 2 pi halves, which is pi, 3 pi halves, 4 pi halves, which is 2 pi, 4 pi halves, not 2 pi halves, 5 pi halves. We're done, right? And if we add this, get this distance here, that would be 4 pi halves, which is 2 pi, and that is our period length, right? Okay, so normal tangent is undefined. -1, 0, 1, undefined. Right, undefined, -1, 0, 1, undefined. That's what it normally is. And then we multiply those by our a, which is 2. So that still stays undefined. This is -2, this is 0, this is +2. And then, so that's is -2, this up here is +2, and then we add our c. And I add our c, which is -3, so we're going to subtract 3, subtract 3, subtract 3. So that is -5, -3, -1. So we're going to come back, we're going to change these. this becomes negative 1, negative 3, and negative 5. And then our graph looks something like a cubic. Oops. Something like that. Okay. Alright, last one, cotangent. So cotangent goes undefined. Next one is at positive 1. Next one at 0. And next one at negative 1. And last one is undefined. Okay? And then it looks like a cubic. Goes this way. And goes this way. Okay? And then we times those 1 by our a, which is 2. It's still 0, and this becomes negative 2. And then we add 3, so this becomes 5. This becomes 2. Or sorry, this becomes 3. And this becomes positive 1. And we can see that distance is a distance of 4. Divide that by 2 is 2. That's our amplitude, right? Period is what's being multiplied by x, which is 1, and our phase shift is the opposite of the inside there is negative pi fourths, and our c is 3. So we're done with those, so now we need to do our x's, right? Normally cotangent starts at 0, so we just add our d, so it's just going to be our d, which is negative pi fourths. We're going to add our interval. Normally period length is pi. We're going to divide that by our b, so it's just going to be pi, right? Pi over 1. Pi over 1 is just pi. That looks like an ugly one. Let's go ahead and fix that. And we take that for our interval length and divide it by 4. So we get pi fourths. So this is 0. This is pi fourths. This is 2 pi fourths. This is 3 pi fourths. And that distance there would be 4 pi fourths, which is pi long. Right? Whenever you have a negative, just add that to your end. Whatever that number is, even though it's negative pi fourths, just add that positive number of that is 4 pi fourths, and that's your period length there. Okay, so there's our graph, all done with that one. Okay, that's it for this video. That's how you graph all the different trig functions.